You're welcome to another video of Juniper Security Associate course. In this section, I will talk about a VPN cryptography concept, which is a prerequisite to understand IPsec VPN concept and configuration, which will be discussed in the next sections. In this section, we will have an overview of basic cryptography concepts such as encryption, authentication, and integrity. Creating VPN connections is the most common solution to secure connections over public transport such as internet. VPN connection creates confidentiality to ensure the traffic is not intercepted by unauthorized persons. We can also make sure that the traffic are not manipulated on the path. In other words, ensuring data integrity. In a long-distance network communication, the other side of the communication is not, of course, beside us. The question is how we can know who we are talking to. Peer and data origin authentication is the mechanism to ensure of the origin of the data and whether the correct sender is sending the data traffic. With authentication, we can also make sure that the content of the traffic is not manipulated in the past. In other words, integrity of data is also guaranteed with authentication. We have two types of VPN communication, site-to-site and remote access VPN. With site-to-site VPN, communication between two or more locations in the enterprise are secured. With remote access VPN, home office and telemetry users are securely connected to the enterprise from anywhere over internet. We have already explained with confidentiality, only authorized parties can read the content of the traffic, and this is achieved by encrypting the traffic. We have two types of encryption, symmetric and asymmetric encryption. Usually, symmetric encryption is used to encrypt traffic because symmetric encryption algorithms are more efficient compared to asymmetric encryption algorithms. DES, triple-DES, and AES are the most common encryption algorithms used in secure communications. DES is the least secure, and AES is the most secure method. With symmetric encryption schemes, two sides of the communication must have the same key. The sender uses the key to encrypt the traffic, and the receiver uses the same key to decrypt the traffic. Encryption or decryption key, it is also called secret key, must be negotiated through a secure channel using key exchange algorithm before starting secure communication. We will talk about key exchange algorithm in a few minutes. Asymmetric encryption is another type of encryption which is less efficient than symmetric encryption. The advantage of asymmetric encryption is that it does not require a secure channel for keys to be exchanged between parties. In other words, public key can be easily exchanged between parties. Asymmetric encryption is not typically used to encrypt large amounts of data, but rather to encrypt small pieces of data due to efficiency issue. The most common application of asymmetric encryption are key exchange and digital signature, which we will talk about in a few minutes. With asymmetric encryption, each side has its own public and private key from party A and from party B. The property of these keys are important because whatever is encrypted with the public key is decrypted with its own private key and vice versa. The public key is not secret and can easily be transmitted without a secure channel, but the private key must be protected. The data is encrypted using other parties' public key. Therefore, only the other party can decrypt the data using its own private key, which is protected by itself. RSA and Diffie-Hellman are the most common asymmetric encryption algorithm. Diffie-Hellman is used to negotiate and exchange secret keys, which will be used in symmetric encryption. RSA is mostly used to generate digital signatures, which is used in peer and data origin authentication. In a few minutes, we will talk more about these two concepts. What is integrity in the cryptography? In remote secure communication, it is not only important to encrypt data to ensure it cannot be intercepted by unauthorized users, but it is also important to know what we are receiving and what is being sent are the same, and data has not changed on the past. In other words, integrity of data must be guaranteed. It is done through hashing algorithm. MD5, SHA-1, and SHA-2 are the most common hashing algorithm. MD5 is the least secure and SHA-2 is the most secure hashing algorithm. To ensure the integrity of the data, a hash of data is generated and added to the data. The receiver recalculates the hash of the data and compare it to the attached hash. If they match, it means data on the path is not being manipulated. What is hash? Hash is a small piece of data generated based on data itself, but it has some special properties. One of the most important property of the hash is that with a given data and hash, it is not easy or impossible somehow to generate the other data with the same hash. Or the other property of the hash is that the hash is one way. This means that we cannot retrieve the data itself from the hash. If you are thinking that an attacker can easily alter the data and replace the hash value with a new hash value, receiver may not notice that the data has been changed. You think absolutely right, and in a few minutes you will see the solution. Authentication is another important concept in the cryptography, which gives two main services. First, we can make sure who is on the other side of the communication and also make sure that the data really comes from other side of the communication and no one else is inserting the data into the communication channel. This is called peer authentication and data origin authentication. Second, we can make sure that data in the past is not manipulated, since integrity alone could not handle it for us, and the attacker could change both data and hash at the same time without noticing the receiver. This is called data integrity. How is it implemented? There are two main methods, HMAC and digital signature. HMAC is based on hashing algorithm and also authentication key. Notice that the authentication key is different key than the secret key which we use in symmetric encryption. The other solution is digital signature, which is based on hashing algorithm and asymmetric encryption, which we will talk in a few minutes. How authentication is implemented with HMAC. Instead of calculating hash based on only data, in HMAC hash is calculated based on the mixture of data and authentication key, and data is sent along with the hash value and without authentication key. In the receiver, the hash is again recalculated in the same way and compared to the attached hash. If they are the same, it means the data in the past has not changed. It also means that the data comes from the originating sender since he has the authentication key. The problem of HMAC is that both parties must know authentication key beforehand. Usually, authentication key is configured manually in both parties. Based on hashing algorithm used in HMAC, the name of authentication method is called HMAC, for example, MD5 or HMAC SHA-1. Notice that authentication key is different from secret key, which is used in symmetric encryption. Secret key is negotiated dynamically through the Diffie-Hellman algorithm, but authentication key is usually configured manually. The other method of authentication is to use digital signature. Actually, this is the best authentication method, but due to the complexity of implementation, it is used in more professional organizations. It is complex because it requires PKI or public key infrastructure. With digital signature, hash is calculated only based on data. Then the hash is encrypted with sender private key. Hash encrypted with sender private key is called digital signature. Data aligned with digital signature is sent through the network. Receiver decrypt the attached hash value with the sender public key, recalculate the hash and compare it with the decrypted hash. If they match, then it shows that data is not manipulated on the path. It also means that data is coming really from the originating sender because the hash is decrypted with the sender public key and the equivalent private key can only be with the sender. With this method, the sender public key is sent via a certificate beforehand, which requires PKI or public key infrastructure, and the discussion of certificate is the outside of the scope of this section. Key exchange is another important basic concept in the cryptography. Key exchange and negotiation is required in symmetric encryption, where both parties need the same key and the key needs to be updated periodically. The Diffie-Hellman algorithm, which uses an asymmetric encryption scheme, is used to negotiate and update the secret key used in symmetric encryption. Algorithm has many versions and group 2 and group 5 are usually used for IPsec VPN communication, which will be discussed in the next section.